just say that you chose, for the sake of argument, 10 to the minus 6, right? Just so we can do an example. Then you actually have to count them. Yes, every little dot on that petri dish. Okay. A lot of people take a fine magic marker and make a dot on each colony as they're counting them, so they know how many they've counted. Is there actually that you don't have to do this? You don't have to count, but that's what you would do. You literally count every single colony on both plates. Okay? So you made 2 duplicates, you've got to count each bacteria on each plate, and then average them together. Add those 2 numbers and divide by 2, right, to get an average from both plates. All right, so let's say that you were to do that. Let's do a practice one here, because this is what your quiz question usually looks like. And actually, your lab practical exam question too. The student in lab did a viable plate count. They counted the 10 to the minus 6 dilution, and they found an average of 167 bacterial colonies. On a practical, you don't have time to count 167, right? So I'll give you the number. Somebody counted for you. They got an average of 167 colonies on the 10 to the minus 6 plate. What that tells you is that there were 167 colonies in this ml of liquid that you put on that plate. Right? So that's all the bacteria you put there. That's wonderful, but we want to know how many bacteria were in the original tube. So now that we've got this number, we have to work backwards with the math to figure out, it's not that bad, to figure out how many bacteria were in the original tube. Okay? So when you actually do that count, that tells you how many bacteria were in the 10 to the minus 6 dilution per ml. You gotta follow that? Because you pipetted a ml of liquid from the 10 to the minus 6 dilution, there were 167 bacteria in that ml. So to work the math backwards, to figure out how many were in the stock culture, you're going to take that average and multiply it by the reciprocal of the dilution factor. Sounds worse than it is. Okay? Dilution factor. That's 10 to the minus 6. Right? If you had chosen the 10 to the minus 7 plate to count, it would have been 10 to the minus 7. Right? It's whatever plate you counted. So remember, 10 to the minus 6 in fraction form means 1 over 1 with how many zeros? 6. So we need to multiply by the reciprocal. What does that mean in math? You flip the fraction, right? This is the dilution factor. So to flip it, 167 times the reciprocal. And anything divided by 1 is itself. So you can just leave that off. Right? And the answer, you don't even need a calculator. You just add the 6 zeros to the end. It's 1 times 167 is 167, and then all of the zeros get tacked on.
I'm like that.
So you have 167. That's bacteria. This is number 3 here. Include the unit. Per ml. That is how much is in the stock culture. And it's per ml because you didn't take the whole stock culture and diluted it. You pipetted a ml out of the stock culture. So all of these numbers that you get are per milliliter. 167 million bacteria per ml. And there's probably 5 to 10 mils in here. Multiply it by 5. And that's how many are in the whole tube.
Wow.
Does that make sense? 13. Doesn't take much room to have that there.
You really don't want us to ever eat again, do you?
You've been eating for all your life and not dying from having that many around. You're fine. Does that make sense? Alright, let's do another one together really quick. Let's say that you decided to count the minus 8 dilution. Minus 8 dilution. Student in lab did a viable plate count for the -8 dilution looked like it had between 30 and 300 colonies, and you found an average of 78 bacteria per mil in the 10 to the -8 dilution. So you're gonna multiply that average by the reciprocal of the dilution factor. What's the dilution factor? Fraction form. 1/1 with 8 zeros. You're gonna multiply that by 78, right, because that was your average. So you can flip it. Which is 78 with 8 zeros behind it. Right, so you honestly don't have to remember step 2 to do the math. I mean, you have to know step 2 in case I ask you about it on a quiz. But whatever the dilution factor is, that's how many zeros you add to the ends of the average. That's all the math we're doing here. Whatever you count, you add that many zeros to the end and you get the answer.
Okay.
See, not so bad. But if this had been the number, 7,800,000,000, and don't forget the unit, bacteria per mil, or you could go with CFU per mil. That's colony forming unit, because you're counting colonies. So you could call it bacteria per mil or CFU, colony forming unit per mil. Bacteria, but you gotta put a unit there, that's part of your answer. If I were to tell you that I had 1 milk, do I have 1 gallon, 1 cup, 1/2 a gallon? How much do I have if I've got 1 milk? You said there were 7,800,000,000 bacteria, does that mean the whole tube? No, it's a bacteria per mil, because remember, that's how many you initially pipette out. So you gotta put that unit on there or the number means nothing. Okay, so, don't forget the unit. That's part of the credit on that kind of question. So we feel comfortable with that?
What about the 10 to the 7, to the -7, 0.1, right,
You'd still do per mil, you'd still do per mil.
per mil?
Because the only reason, right, if we had made a 10 to the -7 dilution, we would have put a mil on that plate. We just cheated and didn't make a separate bottom. Does that make sense? So it's still per mil, that's a good question. It's still per mil. And also because the original stock culture, we pipetted a mil out of it. All right, well, what if I were to ask you how many bacteria are in the 10 to the -8 dilution? How many did you count in the 10 to the -8? 78. Remember, that number tells you how many were in this mil that came out of that bottle. So 78 bacteria per mil in the 10 to the -8 dilution. This number is in the stock culture. Any other questions? Want to do it one more time, or are you good?
Good.
Good?
Just add whatever zeros to the end.
I'm sorry? Yep, whatever one you count, you add that many zeros to the end. But you do need to be able to tell me what the dilution factor is, what the
Right.
reciprocal is, right? Be able to do it, but literally that's all the math you're doing. No, like you're seeing on your tubes, they tend to get bigger when they're more diluted because they've got more space to spread out. You know, tube 1, you've got so many bacteria there that are crowding each other, so they stayed small. But by the time you get to the 3rd plate, they have so much space that they can be bigger. So they tend to get bigger as they have more space to move into. Any other questions? All right, so that's it for Lab 10. Material you'll be quizzed on next Wednesday. I've got a 20-minute video that I want to show you on bacteria. You don't have to take any real strenuous notes on this. I just think it's good for you to see. It gives you some real-world lab experience.